Hello, this is Brad, and today we'll be going over the Math League Test 12107. It's a high school test, and this is going to be target number 6. In this problem we have Duck and Grey Duck playing a game. We see that Duck has a 70% chance of winning a round, and Duck has a 30% chance. Duck has a 70% chance, and Grey Duck has a 30% chance. And each game is just going to consist of they're just going to keep playing rounds until someone wins 2 rounds. So it's kind of like a best 2 out of 3. And so they're going to play until Grey Duck wins the game. Remember, Grey Duck has a smaller chance of winning. And so now we want to figure out what the expected number of games played. And so this might seem hard to figure out at first, right? If we're trying to figure out the expected number, remember that the expected value is kind of like an average. But each game might have a different number of rounds. And so that's kind of hard to wrap your head around. If you try to think about the rounds, you don't know exactly what's going to go on. So let's turn this into a simpler problem, right? Let's just think of flipping coins, right? We're just going to keep flipping coins until you get heads, right? And so what's the probability of getting heads? The probability of getting heads is 1/2. And so if I were to ask you, what's the average number of flips? Coins that you will flip until you get a heads. I mean, if you try to calculate it by yourself, that's difficult. It requires calculus and stuff. But intuitively, right? If you have to make a guess, what would you guess? You probably guess 1/2. Sorry, not 1/2, 2, right? Because if there's a 1/2 chance of flipping heads, then after 1 flip, you have 1/2 of the head. And after 2 flips, you have 1/2 plus 1/2 of the head, which is 1 head, which is what we want. Now that's really informal and not mathematically correct, but that's basically it, right? In this process, the expected number of flips until you get heads is just 2, right? In general, if you have this thing, right, where you keep flipping, where you just keep having a trial or something, and that trial has a success probability of P, right? If you have a trial and success is equal to P, then the expected number of trials until success is going to be 1 over P. So see here what we did is we just took 1 over 1/2, which is 2, and that's what we have. So now let's go back to the actual problem. We want to figure out what the expected number of games played until Grey Duck wins the game. Well, if we can just figure out the probability that Grey Duck wins the game, then we can think of it as okay, the game is the repeated trial, and the probability of success. If we can find the probability that Grey Duck wins, then we can just take the reciprocal of that, and that would be the expected number of games played. So let's go ahead and figure that out, right? You have we're going to draw out all the possibilities of a single game. And the game has at most 3 rounds, so it's best 2 out of 3, So Duck has a 70% chance of winning. So if Duck wins, right, that's a 70% chance. On the other hand, if Grey Duck wins, that's a 3/10 chance. And then let's see what the second round brings, right? In the second round, if Duck wins again, well, in total, that's a probability of 49 over 100, right? 7/10 times 7/10. You also have Grey Duck winning. There's a 3/10 chance of Grey Duck winning this round, so this path has overall 21 over 100. Let's move that 21 over 100. And so we can just basically draw this out, right? Duck wins 21 over 100. Grey Duck wins, this is going to be 9 over 100. In these 2 cases, the game has ended, and we're done, right? But in this case, right, we still have 1 more game to play. And so on the top path, right, that's 147 over 1,000 will be the probability that Duck wins again. And on the bottom, the probability will be 3/10 by 21 over 100, so that's 63 over 100. Similarly, over here, right, if Grey Duck wins again, right, that's going to be 63 over 1,000, so over 1,000. And so if you see all the possibilities like Grey Duck wins, you have 63 over 1,000. plus 63 over 1,000 plus 90 over 1,000. And so this is the total probability that Great Duck wins. This is 216 over 1,000, which is equal to 27 over 125. And so you can plug this on it, right? And so if the probability that Great Duck wins is 27 over 125, then basically what we've done before, right? We can just take the reciprocal of that. And we can take 125 over 27 is the expected number of games played. And so yeah, that's basically the entire way of how to do this problem.
Hi everybody, this is Tim. Hope you're enjoying our videos. If so, you know what to do: like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.